The lesson today will be a continuation of what we did yesterday. You're just going to notice that the problems may be slightly different because of the information that they give us. I went ahead and copied the formulas from what we did yesterday so that you could use them for reference on these notes. But it's just, you may have to find other information first before you can actually find the sum of the series. And so just trying to give you kind of an introduction as to where we're headed today. So we're still using the formulas, just having to maybe find different information at first. So we're going to dive right in and go ahead and look at the examples so that you can kind of know what you're doing on your practice problems. With the first example, it says determine the sum of each series. The way that you start this one will be the same way you started the problems yesterday. You have to first figure out what kind of sequence it is. So look at the pattern, figure out what's going on there. If you think about it, trying to figure out if it's arithmetic, you're going to think, okay, am I adding a constant number? And so something that draws my attention is to go from like 13 to 20, I'd have to add 7. So if I take 6 plus 7, do I get 13? And yes, I do. And so that means that it would be arithmetic. And so remember, if it's arithmetic and they're asking you to find the sum, you use the formula for an arithmetic series. So if we're finding the sum of it, we're going to use that formula. And remember, I kind of write it a little bit different. The only issue that you're going to find is the first thing that we have to know is what n is. And remember, n from yesterday is how many terms you're adding up. And we do not know that. So we will have to come back to that. So I'm just going to copy it down. And then the way that I do it, remember, I put all of it over 2 instead. And so I'm going to write it the way that I've been writing it. And so your first term, just looking at my formula, is 6 in that sequence, and then it's plus. The good thing about today is we actually know what that last term is that we're adding up. So we're going to add in 69 would be the last term that we add in. And then all of this is over 2. Okay, so now we have to go to the side and we have to figure out what is n. Okay, so I'm going to go to the side just like I did yesterday. And remember, the explicit formula can actually be used to help you find other information than just a term in your sequence. And so I'm going to copy down, it's arithmetic, so I'm going to copy down the arithmetic explicit form, okay, or formula. So that formula is a sub n equals a sub 1 plus n minus 1 times your common difference. So this will be a little different because we have to find n this time. And so remember, n is the position of the term that goes here. And so technically, to be able to find n, which is how many terms we're adding up in a way, we just have to figure out what is the position of this term. So we're looking for the position of that term right there, okay? So that's actually the term we plug in for this, okay? So we're going to plug the 69 in right there. And then the first term, remember, is whatever the first term is, or the first number that you're adding in, plus, and then we're looking for n, so it's going to stay the way it is. And then we have to figure out what is my common difference. Remember, common difference is whatever number that you're adding. So that would be 7. And now we just have to solve this. So to solve, we got to subtract the 6 first. So then 69 minus 6 is 63. So those would go away. And then I have n minus 1 times 7. Now you have an option here. You could distribute your 7 and then solve it like normal. Or I noticed that I'm taking this times 7. So what I'm actually going to do is I'm going to divide by 7 to get rid of my 7. And so 63 divided by 7 ends up being 9. And I'm going to go ahead and move my n minus 1 to the left side since it makes it easier. And then I just add 1. And so n would be 10. So the position of this term would actually be, this would be the 10th term in my sequence. So now all I have to do is go back over here and erase my n and plug in what the position of that term was. So it would be 10. So technically we are adding up the first 10 terms of my sequence. And so once I find that information, just gotta plug it in my calculator. And when I plug it in, I end up getting 365, or excuse me, 375. So if I actually wrote that whole sequence out to the 10th term and added them up, it would end up being 375. So let's do one more kind of like that, and then we'll do some that are a little different. All right, so same thing. I'm going to find the pattern. What am I doing to go from one term to the next? So if I thought that I was adding the same number, if it wasn't obvious, remember I take one term minus the term before it. So when I take -8 minus 5, I get -13. And so if it's arithmetic, that would be my common difference. So that means I'm subtracting 13 each time. So check it. -8 minus 13 should be -21 if it's arithmetic, and that does work. And so that means this one's also arithmetic. And so we are finding the sum of this series, and we knowing that it's arithmetic. So we use this formula again. Okay, so we have the same issue though, because we don't know how many terms we're adding up. So we're going to have to go to the side just like what we did before, and we're going to have to figure out what n is. So before I do that, I'm going to go ahead and plug in the rest of my equation. So looking at my formula, I have to find the first term, so that's what goes there, plus whatever that last term is that I'm adding in, which would be -190. And then all of it's over 2. So once I find my n, then I can very easily just plug it in and then plug that in my calculator. So I'm going to put a little dividing line. So I'm going to use that same equation, except I'm going to go ahead and plug in. So remember, the term that goes here is whatever is that last term that we're, I guess, trying to find the position of. So the last term that we're adding in there was -190. And then that equals the first term. So my first term is 5, plus we're looking for n, so that part stays the way it is. And then we're multiplying it times the common difference. The common difference was -13. Okay, and then I'm going to solve it just like I did the other one. So I have to subtract my 5 so that this will go away because I'm adding it. So I have to subtract it. And then I get -195 on this side. And then I have n minus 1 times -13. So again, I could distribute my -13 and solve it that way, or I'm just going to go ahead and divide by it since I'm multiplying by it so that it'll go away. And then I have n minus 1 equals whatever we get there, which ends up being 15. And then I add my 1, so n would be 16. So what we just found is actually the position of this term. So this would technically be the 16th term in my sequence. So really, when we add up this sequence, we are adding up the first 16 terms. So I'm just going to go back in and plug it in. And then I plug that whole equation in my calculator. And then I end up getting -1,480 as the sum of the first 16 terms. Okay, so what do we do when they give us information in a different way? Well, this is just kind of practicing that. So for these next few problems, it says determine the sum of n terms for each geometric series. So they're telling us that it's geometric, okay? And so that means we're going to be using this formula up here, all right? So make sure you're using the right formula. So for number 3, it says the first term is 6, the common ratio is 2, and then n is 9. So this technically means we're adding up the first 9 terms. So in my formula, we're finding S sub 9. And so all I'm doing is I'm going to see if I can get both of these on here at the same time. I'm using this formula and I'm plugging in, and then if I have to find something extra, I will, kind of like in the other problems. But if not, then we can just plug it in. So my first term, they tell us is 6, so I'm going to plug that in. That's times 1 minus the common ratio. So it'd be 1 minus, my common ratio is 2. Remember from yesterday, make sure you put that in parentheses. And then it's to the power of n. So n is 9, because we're adding up the first 9 terms. And then it's all over 1 minus my common ratio, which is 2. So we have all our information. So all we have to do is type that in. And then when we type it in, we get 3066. So if I actually wrote this out, the first 9 terms of this sequence, which you could, and I added them up, I would get 3066. Okay, so the next one, same kind of thing. We're finding the sum of the first however many terms. So the first term is 729. My common ratio, what I'm multiplying by is -3. And then I'm adding up the first 15 terms. Okay, so my first term, I'm just looking at my formula here. My first term is 729. And then that's times 1 minus my common ratio is -3. This is the big reason why you have to put it in parentheses. And then it's to the power of n, which is 15. And then all of that is over 1 minus my common ratio, which is -3. And then you type that in. And I think this one ends up being a big number. Yep, it ends up being 2,615,088,483. So in other words, if you wrote this out, the first 15 terms of this sequence, and you added them up, this would be what it adds up to equal. Okay, so, oh, sorry, you guys couldn't see that. So the last problem is kind of a little bit different because I wanted to give you one that kind of gives you different information. So number 5 says a geometric series has a sum of that. So that means when they added it up, the sum of however many terms that they added up actually ended up being that. So they gave you what it added to be, okay? And it says each term increases by a factor of 5. So when they say it's a factor of 5, that means that they're technically multiplying by 5 to go from one term to the next. So that's actually your common ratio. So they told you that your common ratio is 5. And it says if there were 7 terms in all, find the value of the first term. So this means that there were 7 terms that they added up. So we can actually go back and fix this because they told us that they added up 7 terms. So this is actually the sum of the first 7 terms of that sequence. And what they're wanting you to find is what is the first term. Now, there's 2 ways you could do this problem. You could think about, okay, well, this is the sum of it. And you can kind of try to reason through it, which would be a little harder. Or you can use the formula. And so since they're giving us the sum, what I typically do is I write down the sum formula, and they said it was geometric. So I'm going to write down the sum formula for a geometric sequence. Just copy it down. And then I'm going to plug in everything that I know because the first term's right here. I'm looking for that. So if I know everything else, then I can solve for that term. Okay. So I know that they added up the first 7 terms and it equaled that. So this is actually what I put for my sum. Okay. So notice I'm going to put -19,531. That's my sum. I'm looking for my first term, so it stays the way it is. And then that's times 1 minus. They told me my common ratio was 5, so that's what goes there. And then again, you can put in parentheses. And then it's to the power of n. Well, remember, n was 7 because they added up the first 7 terms. So that power would be 7. And then all of this is over 1 minus, well, my common ratio is 5. So notice I know everything in this equation except for my first term. So all I have to do is solve. This, the a sub 1 is actually being multiplied times that. So all I have to do is type that in my calculator to figure out what that is. And then I know what this is. 1 minus 5 would be -4. And so I'm going to simplify it a little bit. So when I do that, I'm going to bring my 19,531 over. And then I have a sub 1 times, when I type this in my calculator, I end up getting negative 78,124. And then all of that was over 1 minus 5 was negative 4. And so from here, we're taking this, we're multiplying it times that, and then dividing by the negative 4. So to get the negative 4 off the bottom, you do the opposite. So I'm going to multiply by negative 4 on both sides. So after multiplying by negative 4, we end up getting a positive 78,124. And then after that, you would just divide, because you're multiplying the first term times the negative 78,124. You divide by that on both sides. So after you divide by that on both sides, you end up getting negative 1. So there you go. Let me know if you have questions. Have a good day.